So very pleased to have you all here. This is another one of our sort of topics in development and the environment. And we are in a developing country today, but it's in the U.S. going back a few years. Very pleased to have Karen Clay here. I sort of heard about her through my colleague Matt Turner, who was colleagues with her at Toronto, and a lot of interesting work on using historical data, largely looking at climate change and various things. But today she's talking about resource curses. So, Karen.
Okay. So, well, thank you so much for coming. I, have had a great time. It's been really fun to see what Brown is like and meet a lot of really interesting people. So today we're going to talk about when are resources curses and blessings. This is joint work with Rita Portnick, who's at Carnegie Mellon. And this particular picture is from the Bakken today. And as you may know, the Bakken's been experiencing a huge resource boom. But this is just sort of one example of many examples where you've seen resources both increase and decrease in states at different points in time in the United States. So one of the things we're going to be doing is using the long historical record from the United States to try and really look at these issues of resources and their relationship to growth in per capita income to better understand what's going on. But before we do that, I want to start at the beginning. So if you haven't seen this before, Sachs and Warner published a paper in 1995 that sort of set this literature off, right? And the term resource curse probably predates them, but certainly came into fashion in economics as a result of their paper. And so what you can see is that they have a graph where there's exports of natural resources in percent of GDP in 1970 on the horizontal axis, and on the vertical axis you have real GDP growth from 1970 to 1989. And the thing you're supposed to notice is that there's a negative relationship between these two things. And this is what they call the resource curse. And the thing that then happens is not only is there a sort of subsequent explosion in the literature that looks more closely at these stylized facts at different points in time and different subgroups of countries and things like that. But you also have another subliterature which really says, okay, conditional on having a resource curse, how do we go about avoiding it? And this, this literature is influential in part because this is something, for example, that the World Bank takes very seriously. You have some high-profile people like Jeff Sachs and Joe Stiglitz writing books on this issue. And if you have looked on Amazon and you type in under Amazon books, resource curse, you get something like 117 hits, right? Which is crazy, and many of those things have it in the title. Right? So these are books that are on the resource curse. So they're just an enormous literature. And one of the things that's sort of frustrating about the literature, and also frustrating about the literature in the US context, is that this is a very conflicting literature. Right? This is a literature, some papers say yes, they're a curse, others say yes, they're a blessing. Some say there are conditions under which one or the other happens. And so part of this in terms of why am I working on this was my annoyance with the fact that people weren't using, so I'm an economist, but I'm also an economic historian. People weren't using the long historical record from the US to really try and understand this. And people weren't going at this in a kind of integrated way. And so I was really just interested in trying to better understand why is this literature so conflicting and what, if anything, can we do? I'm not going to talk too much about this second piece, which is the policy relevant piece, in part because this paper is really about trying to understand what is happening, what are these empirical relationships. But I can tell you that the governor of North Dakota or the governor of Pennsylvania or the governor of any of these states is going to be interested in what can I do to avoid the resource curse, right? If you're a relatively resource intensive state, are there policies that we can put in place that are going to ensure that our state actually gets something beneficial out of this long-term reliance on resources? Okay, so what does this paper do? Well, first of all, we're going to produce new estimates of the resource curse We're going to use the long historical data. So we're going to go from 1935 to 1999. And you might think, why are you not going up to 2015? That's in process. It turns out there's a big change in the data series in 1999, and so it's a little bit more complicated to integrate that, but it's coming. We're going to look at 3 important categories of resources: oil, coal, and agriculture. And again, there may be some sort of more minor expansion in coverage. We're also looking at heterogeneous effects. And what do I mean by heterogeneous effects? Often the literature is going to look at a single measure of resources over a time period and say, this is the relationship, right? This is the coefficient, if you're an empirical person in the audience. And what we're interested in part, is understanding, are these effects different for different kinds of resources? Are these effects different in different time periods? Are these effects different over different time lags? So often the literature says, we see an increase in resources today. Does that affect growth today, right? Well, you might imagine these things would take a little bit of time to manifest. So you might think that a 1-year time horizon is not quite the right way to go about looking at it. So we're going to look at that. We're also going to look at whether there's asymmetries in increases or decreases, and whether there's effects in periods of high and low growth. We're also, because we're interested in this sort of developing country context, we were interested in looking at differences between the South and the non-South.
Just before you're going to miss, since it's all the United States, any currency appreciation effects, right?
Yeah.
So that's not quite going to be relevant to the developing world, I presume. But maybe you have something to say about that.
Right. No, I mean, so we're looking at a fairly circumscribed piece of that, and the whole U.S. literature has had that issue. But I think the implication for the developing country literature is much more about the fact that you need a more nuanced analysis, right? You need better data. You need to look at things individually. So the results might be different in a developing country context, but I think the sort of lessons here in terms of wanting to do and needing to do a more nuanced analysis are actually pretty important.
So should we be thinking about agriculture differently than oil and coal? I mean, agriculture is land that people choose to convert into, that type of resource, whereas oil and coal are just there in the ground.
Uh-huh.
So how do we think about, should we think about them in the same way, or how do you?
Well, that's a good question. We're going to look at farmland in a particular point in time, in part as a kind of proxy for your endowment of arable land that's suitable for agriculture. It turns out that that's pretty highly correlated over time, so whether we look at it in 1935, which is what we're going to do for our base year, or whether we look at it in later years doesn't matter too much. So in some sense it is an endowment, like oil and coal. In some ways it's a very different, because of course, you don't just extract it once. It's an ongoing thing. And you'll see that may account for why we're getting somewhat different effects of agriculture. Part of the motivation for us to look at agriculture is when, if you go back to the Saxon-Warner thing, and I'll talk a little bit more about this later, but their view of natural resources is all primary products, which basically includes metals, non-metals, fuel, and all of agriculture, right? And so this literature has been, I think, a bit sort of, part of the reason for the conflict is because there's no consensus on what the right measure of resources is. Okay, so what do we find? We find that as you might have expected, the relationship is going to vary. Why is that important? That's important because if you were looking to support, resources that are a blessing, and you were being a little bit, disingenuous, you could cherry pick specifications that would give you that. And similarly, if you wanted to say, resources have no effect, you could cherry pick specifications that would say that. We don't find too much evidence of a traditional curse, and what I mean by that is literally you see an increase in resources, and then you see a decrease in growth, right? That we don't see. So that would be sort of a negative coefficient. What we do see, though, is some asymmetric effects of increases and decreases. So what do we mean? There's a boom, things look good, per capita income grows. There's a bust, but it goes down further than before. And this is consistent with some studies that have looked at specific sectors in specific states and found that indeed the boom-bust, basically after the boom-bust cycle, some of the counties are worse off than they were before. We're also going to find these interesting, and I think we're still working on the interpretation, so if you have ideas, you can help us out here. In terms of the asymmetric effects of normal and low growth. And we have some ideas for what they might be, but we're definitely still working on what that would be. The other thing that we do is we actually do some replication. And the main reason we do some replication is because this is a very conflicting literature. And the way that we could figure out whether it was that we were using different data or what exactly was the cause of the different results was to just do the replication exercises with our data. And in some cases, we reached out to the original authors to get the data. This is something that, again, I think particularly the international literature would really benefit from because, in a lot of cases, the differences are really related to these different specifications. Okay, so before we go into the kind of empirical analysis, I'm going to talk a little bit about a model, which is due to Alcott and Keniston, but I think should be hopefully easy to access for everyone, which is a domestic Dutch disease model. And if you aren't familiar with this, Dutch disease is literally what happened was there was a big natural resource boom in the Netherlands. And so there was a big increase in resource employment, and there was during that same time period, a big decrease in manufacturing. And so it came to be known as Dutch disease. I'll explain the intuition in a minute, but that's why it's got this slightly funny name. It's in a common currency area, which is what Andrew mentioned. It's within the United States, in an area with imperfectly mobile labor, right? Which is just going to mean that people move around, but there's going to be some friction in the system. Okay, so here's the logic, right? I mean, I'm not going to show you the math behind the model, but here's the logic of the model. It's pretty straightforward. In these kinds of models, what you see is that resource employment increases, causing wages to increase, right? Because there are a finite number of people there. Wages also rise in the traded, or you could think of as the manufacturing sector. Employment declines in the traded sector, and then you get these changes in growth. Okay, so typically, the model is going to focus on these negative externalities, although in principle, there could be either negative or positive externalities. So when people estimate these kinds of models, what they often find is that there's some kind of loss of learning by doing in the tradable sector. All that means is that if you get better at manufacturing things, the longer you do it, then if you shift a big, a lot of the sector to other things, or all of the sector to other things, then you don't get the benefits of that production, and so you have slower growth as a result of the fact that the manufacturing is expanding more slowly.
Non-economist asking, what is a tradable sector?
You should think about that as kind of loosely manufacturing.
Okay.
Yeah. Yes. No. You should ask questions.
Other stuff isn't tradable?
Anything that you would ship to, you could think of as shipping somewhere else, is tradable.
So construction is usually non-tradable because you can't move buildings.
Okay.
Yeah. Haircuts are non-tradable.
Natural resources are also tradable.
Yeah. Right. But we're going to think about those as being different, right? So they are tradable, but we're sort of separating them out from other tradable things. Okay. So there's this loss of learning by doing. So the point is, people often find that there are these negative relationships, but there can be positive ones, and in fact, Alcott and Keniston find that there are positive relationships in their analysis. It can come from a variety of dimensions. Let me just give you one example. The resource boom could affect the relative input costs. So here, what you should think of is you're a refinery in Texas, and a boom in Texas helps you because you get more domestically produced oil and you get it at a slightly more favorable price. Now, there can be other reasons. Almost any kind of complementarity between the resource sector and the manufacturing sector, the tradable sector, will do it, right? But this is just one example of something that might do it. Okay, so again, I'm going to hopefully be able to explain these things in ways that are accessible to non-economists. You should stop me if I. So like Alcott and Keniston, we're going to use this thing that's called the Bartok shift-share approach, which is not as kind of horrible as it sounds. So here we go. You want to start with this alpha. This alpha is going to be a measure of a state's endowment of resource R, right? And so I'll tell you more about this alpha and how we construct this alpha a little bit later, but now you should just think about it as a measure of the endowment. And what we're going to look at is we're going to look at a change in either E, which was E in their model because they were very focused on employment. Sometimes we're also going to use income. And the reason we're going to use either employment or income is that those are actually somewhat different measures, right? So you can imagine that employment could be going up or down, but also income could be going up or down because there are changes in commodity prices worldwide and domestically. Okay, so we're going to look at the relationship between a change in national employment interacted with your endowment, and how that translates into a change in growth, right? This thing is one representation of how economists would represent growth. And we're going to estimate this for different resources, so different taus for different resources. We're also going to control for a bunch of things flexibly. So we're going to control for the fact that different states in the base year, so we're actually going to take the average of the 1929 to 1934 income. That's just going to capture the fact that at the beginning of our period, some states are poorer than others. And we're going to allow that to be interacted with time, which is just going to allow the fact that those states may be trending differently. We're also going to include some controls for division, and we're going to allow division to have year fixed effects. Census divisions are sort of census regions that are grouped geographically, and so you want to think about this as like, say we think that the North Central is doing badly because of something having nothing to do with resources, right? So that's going to control for that as well. Okay, so one thing that, if you're an economist, this is a side note for the economists, is that, yeah, Matt?
So the Y has two arguments on it, and the alpha has two arguments on it, but they don't mean the same thing, right?
Right. This is because this is an endowment measure, so it's not time varying.
Okay, so what's the second argument what's the first argument on the Y on the right-hand side? In the estimating equation,
yeah.
the Y on the right-hand side,
yeah.
What's the first argument on it?
State I and time T.
And
we're going to allow there to be
keep on next term.
Okay.
There's the one that's being multiplied by omega.
That one?
No, further. I think you got your 0 and your t mixed up.
Yeah.
Oh, okay.
It should be,
Yes, yeah, it should be. You're right.
I0.
Yeah, it should be I0. In fact, I think it's
Yeah, it's there.
it's correct there. Sorry
Oh,
about
I
that. Yeah, sorry about that. Okay, so does that clarify?
Yeah.
Okay, so I will fix it in the next version of the slides. The thing that these Bartok shift-share units, shift-share approaches are often used in economics. Often they're used as an instrument. Here and in Alcott and Keniston, they're not being used as an instrument. They're being used directly because it doesn't satisfy the exclusion restriction. Okay, so we're going to be looking though at the relationship between these changes here and these changes here. Okay, so we're going to look at a variety of heterogeneous effects, and so as I mentioned, we're going to look at different resources. We're going to look at different time frames because we think that the effects may manifest over different time frames. As I was talking to somebody, one thing that we use a 1 year and we use a 5 year, and primarily that's for convenience. It's not a priori obvious what the right time frame is. It's just that when we expand the series a little bit, we may be able to go to a 10-year time frame, but right now we're going to stick with the 5-year time frame. We're going to look at the period 1935 to 1999. As I said, the series changes in 1999. We're eventually going to expand it to 2015, and we've done some preliminary work. But since this is being videotaped, I didn't want to be videotaped with anything that I wasn't quite sure about. And then we look at 2 subperiods, which roughly correspond. People often focus on this later subperiod when they're doing stuff on the resource curve. So part of the reason to subdivide the period is to think about the period where we have some additional historical time. So you should think about this as roughly from the end of the Depression through 1969. But then this is the period that people often look at. We're going to look at increases and decreases in resource income, so we'll allow that to be flexibly estimated. We'll look at low and non-low national growth, and across the South and the non-South. So one of the questions you might have is, what is a resource? And this kind of comes back to your question earlier. Sachs and Warner's main measure was this kind of slightly weird measure of fuels and non-fuels, including food and live animals and beverages and tobacco and animal and vegetable oils, fats, and waxes, as well as non-ferrous metals. So it's this sort of slightly strange measure. In the US, people have used a variety of measures, including coal. So if you're familiar with the black paper, they look at what happens to coal counties. Coal, oil, and natural gas is often used. A lot of focus on oil and natural gas, or both, including a bunch of papers that really look at the effects of the fracking revolution. One thing that's sort of interesting about those papers, of course, is that we're only on the upside of the boom right now. So we haven't seen the downside of the boom. And that's fine. It's still informative because these papers suggest that these are benefiting the areas, right? That the money is actually benefiting the people in the areas, because there was some concern that maybe even that wasn't happening, that they weren't creating extra jobs and so forth. And so there was some work on that. There are a couple of other papers that look at primary products, which is basically similar to the Sachs and Warner. And so they look at agriculture, forestry, fishing, and mining. And so part of the reason to sort of look at agriculture as well as oil and coal is to capture more of the primary products. We're going to use endowments. Sometimes we're going to aggregate oil and coal just because reporting 3 sets of coefficients is sometimes a little bit of a hassle. So we've got fuel, minerals, and agriculture. And here's my picture, because it's good to have pictures, especially in general talks, keep people awake. Okay, so one of the questions you might have is, how do we measure endowment? And we're going to look at reserves of oil or coal or land in a given year, and that year is going to be mostly 1935. We've experimented with other years because we're concerned about sensitivity, and it doesn't seem to matter a lot. 1935 is the first year that we could get reliable, or what we believed were reliable estimates of reserves. One thing you have to do in this kind of analysis, or one thing you should do, often the scaling is as a share of GDP, but that has some endogeneity problems. And so the question is, how are you going to scale this in a way that makes sense? Because Rhode Island is Rhode Island the smallest state in the Union?
Yes.
Yes, okay. Rhode Island's really small. Pennsylvania's much bigger, where I'm from. Texas is even bigger, right? And so it doesn't make any sense at all to think about these things unscaled, because of course Texas potentially is just going to have more because it's bigger. And so after experimenting with some other things, we decided that what Alcott and Keniston did is probably the right thing to do, and then we scaled by square miles.
Not by people.
In 1935, here's the problem. So we did look at people, and we thought hard about this, but of course population in 1935 looks very different than population today. And so the problem is that, it's not clear you're quite capturing what you want to capture. But we definitely did that experiment and thought about it. For E, we're going to look at sectoral employment or income. They're looking at Dutch disease, so they're very focused on employment. But as I said, we're actually interested in income as well. One of the reasons to be interested in both is when you're looking at a really long time period, coal in particular and agriculture have experienced enormous productivity improvements, such that the number of workers has fallen even as the output has stayed relatively stable or even risen. And so you actually want to at least in theory, look at both. These are, just as I said, to capture anything that might be happening either based on initial income or based on census division. So our data, the state income data come from the BEA and population from the censuses. I should mention, because this actually is pretty important, that we exclude Alaska, Hawaii, and the District of Columbia. And the reason we do that is partly because Alaska and Hawaii come into the data relatively late. District of Columbia is, its own funny little beast. But the other thing, and they're not contiguous to the United States, is that Alaska is a huge outlier in so many ways in terms of its resource dependence. And so it depends on, you can include Alaska, but it depends on what you think you're going to learn. It turns out that even in the kind of cross-sectional literature, the results are very sensitive to including or excluding Alaska, right? You're much more likely to find an effect if you include Alaska. So we generally have chosen to exclude Alaska because we think that it's not necessarily relevant for the rest of the United States' experience. This just gives you a sense, if you're not familiar with it, of what's been happening to income per capita over time in real dollars in, I think, 2010 dollars. Yeah, maybe it's in 1990 dollars. Here is the growth, and you could just see the distribution. The average in this sample is going to be 2.5% growth, but you can see that there's a pretty wide distribution over the course of the sample.
And the units are states on that?
The units are states, yeah. It's a state. A unit is a state year. The value of the endowments is coming from the Minerals Yearbook, and we're going to base it in 1935. State farmland is in 1935 as well from the Census of Agriculture, and then there's national employment and income data from the Bureau of Labor Statistics.
I'm still worried about the endowments being very different in 1935 than they are in 2000. Is that, am I worried about something I shouldn't be?
So part of it is we haven't tested 2000, right? What you want is something that's at least plausibly somewhat prior to the period you're looking at. So we look at, the endowment 35 and go from 36 on. We actually did some of the analysis when we just used the endowment in 1960, even though we were still using 35 to 99 just to see if it had any impact, and it didn't actually matter very much. It turns out the endowments are pretty highly correlated. The thing that might happen if you go to 2000 is there are some things like there's been a lot more production in the Powder River Basin, presumably because there's been more, some discoveries, for example. So, it might matter a little bit later as we get to the end here. And certainly the fracking revolution, the discovery of economically viable shale extraction has changed things as well. But, part of the reason to do this, as long as you think it's not going to change the relative shares very much, which it might not, because, for example, a lot of the fracking has been happening in Texas, which was already pretty resource intensive. So it would have to be something that really shifted the correlation is the bottom line. Because otherwise the endowments, because we scale them, like the one that's number one now would be the number, one that's number one in potentially 1935, but we can certainly check that. Okay, so this is a little bit to your question, right? So this is showing you what are the resource endowments in 1935. So here is, Texas and Oklahoma and Louisiana, California, Wyoming. So it gives you a sense that even on a per square mile basis, it wasn't a priori obvious to us that this was going to turn out this way. It could have looked different, but it actually looks pretty reasonable. And then we rescaled. So remember, we're scaling the endowment by square miles. But since that's not an interpretable thing anyway, we decided to rescale it so that the top one is 1 and the bottom one is 0, and then their relative position is based on the endowment.
When was Standard Oil broken up?
Yeah. Mhm.
before this, right?
Yeah. Okay, agriculture. Again, interesting that the farmland per square mile is exactly kind of where you think it would be. But again, it wasn't completely obvious to us that that was going to be true. For coal, you've got the Appalachian coal, you've got Illinois coal, Colorado, North Dakota actually has quite a lot of coal too. So the point here is that the distributions actually look relatively sensible. And here's when you combine oil and coal. This is what's been happening to employment, because remember, we're going to be interacting the baseline endowment with changes in national employment. And the idea there is that places with greater endowments, when we see increases in national employment, should be seeing greater changes themselves. Now, if you're an economist, you might say, are you worried about the fact that my state's employment may be affecting national employment? And the answer is, we looked at this and it didn't change the results very much when we extracted the state's effects. So we haven't bothered to change it in all of the graphs and tables, but we can, and it may be that when we submit this for, that the referees will require us to do it. But right now, Texas's employment is still in the national figures, for example.
Just two questions about the graph. If you look beyond 2000, what would happen to the oil and gas line?
It would go up some.
Is it up higher than like the early 80s, or?
I just saw this and I don't remember. I also saw the coal one, and the coal one continues down.
Which one is coal?
So I apologize. We should have made these better and more distinct colors. This is the blue line. The blue line is coal. So you can see that it's sort of up around 500,000, drops down, and then continues to drop further. So big declines in that. The interesting thing is, because we're not producing a whole lot of oil in 1930, you see it sort of gradually increasing and then going way up during the oil boom, or during the early 80s, and then beginning to trend down after that. So yeah, my guess is that it would go back up. I don't know offhand though. All right. The other thing, since we're controlling for income per capita in 1929 to 1934, I thought I would just show you what it looked like. Interestingly, the Northeast is very wealthy, including presumably Rhode Island. Rhode Island is like right there. It's a little hard to see in the thing, but anyway, the Northeast is quite wealthy. Illinois is wealthy. Interestingly, Nevada's pretty wealthy, which is, I think, the fact that there are very few people and a lot of mining. And then California is pretty wealthy. So we're going to, again, flexibly allow this. The other thing to notice, of course, is the South is quite poor, and we're going to be expecting to see some catching up in the South. We're not going to explicitly look at that, but that's one of the things that we're going to.
And this is mean income per capita, not median household income or something like that. So you can have mining revenues that make a few people very rich.
Yeah.
The population remains very poor.
Yeah. No, that's right. This is average. This isn't anything other than that. Yeah. Okay, so this is the first table, and what do I want you to notice about this? The first thing I want you to notice is that all of the coefficients, both on minerals, I'll show you some oil and coal in a second, on minerals and on farming are positive. And the ones on minerals are statistically significant. The ones on farming are generally not, but they are positive. This one is. The other thing, although this will be clearer when we get to some later stuff, is that there's at least potentially going to be this difference between when you use a 5-year window and when you use a 1-year window. If you're an economist, we're also clustering the standard errors at the state level, and we've done some experiments with bootstrapping because we were interested to see if that would matter, and it didn't seem to matter very much in terms of the standard errors. Okay, so this is just sort of the intro. This is when we subdivide it into oil, coal, and farming. And what you're going to see is that in the blue box, this is the 1-year interval. So again, we're assuming that a change today has an immediate impact on, whatever outcome, in this case, growth in per capita income. And so maybe there's a little bit something there, but in general, not statistically significant. When we go to the 5-year, which gives a longer period over which you can see some effect, right? So maybe there's a change today, but maybe it takes a little while to propagate. You see that these are positive and significant, and that's true for all of these, interestingly. In general, in some other specifications, we're going to find less of an effect in farming for some other specifications. The way you should interpret this right now is these are positive. This suggests that there's probably perhaps a resource blessing. And the magnitudes, so this would tell you, for example, that the top state, this is going to be, so if the top state, for example, is, actually I don't know what the top state is offhand, it's either Texas or Oklahoma, but in the top state, this would be about a 20% increase in growth, right? For a 1 standard deviation change in employment. Okay, so basically that's a big effect, right? If you, in terms of what would be happening here. Okay, so main takeaway here is just that it's positive and significant, and it looks like the 5-year effects are bigger. You're seeing similar things. This is now the income, so before we had the employment, and this is the income. And again, you're seeing similar things, although less in the farm sector. Okay, so let's just take stock before we go into the next set of sort of analyses. What do we want to say about this? First of all, the effects may take time to develop, so this idea that you're going to see a 1-year effect, which is the thing that's sort of most commonly estimated, would give you a different interpretation, right? So you do want to be a little bit careful about that. The other thing is that resources appear to be blessings or to have no effect. We don't see any evidence so far of that negative coefficient we talked about before, right? The idea that you would have an increase in resources and a decrease in growth, which is one way you would see a resource curse. But one thing to notice is so far we've forced the effects of increases and decreases to be symmetric. And that obviously could be important in terms of thinking about what's going on.
I'm sorry, I've lost this detail of manufacturing. That's here or not here in these numbers?
Right. So the way that this literature has developed, we have resources and then we have sort of other stuff. So we actually don't have manufacturing in here explicitly, but the idea is that if you saw a negative coefficient, right? Right. The curse coefficient, that's coming in through manufacturing, basically. You're drawing things into this sector.
But you're looking at employment in total, and so...
We're looking at employment in the resource sector.
So if manufacturing employment went down, would that be reflected in any of these numbers?
Well, so implicitly, what they're arguing is if this went up, at least if one thing that could happen and one reason for a negative coefficient would be exactly that manufacturing employment went down.
Okay.
Yeah.
Or if you see a 0 effect, that would be consistent with the idea that manufacturing went down and the resource employment went up, right? Is that what you want to...
Yeah, but then, I mean, it also implies that there was no adverse effect in the sense that there was no negative externality, right? Which could be possible.
Right, but the simple sort of movement of job, sort of
exactly.
Perfectly non-tradable, or labor is totally immobile, people just move from one sector to another.
Right, there's
You see a 0.
You could see a 0, yeah.
Okay.
Okay, so does that?
Yep, it does.
Yeah. Okay. All right, so effects take time to develop, appear to be blessings or no effect. So we're going to go to the asymmetric effects now, and we're looking at a decline in oil or this is the baseline effect. These are differential effects, so you should add up these effects to get the total effect. We'll talk a little bit more about interpretation, but the important thing is they're differential effects if you're used to looking at this. And coal, and then farming. So what you see, for example, is that there's a positive and significant effect for increases in oil, say increase in oil employment. So let's look at this column. So this is an increase in oil employment, but this says that the coefficient is much bigger when you're on the decline, right? And so here, say there's a 1% increase in employment, then you're going to get 0.68, except it's going to be a couple more zeros. But the point is, it's going to go up, but then it's going to go down by more than it went up, right? That's what this means, because the same effect is going to go up by this amount, but go down by the sum of these two. Okay, but you may notice a couple of other weird things which are going to suggest that we want to explore things further. So before we get too focused, first of all, there's a bunch of things where it looks like the effects are kind of variable. But secondly, there's this. Right, so here it looks like it's positive, going down is bigger than going up, but then there's this, what's happening over here when we're talking about resource income and this time period. Okay, so the other thing that's in the literature, right, so the literature has this boom and bust element, right, and there's a sub-story about boom and bust, but there's also a sub-story about recessions, and recessions having an impact on resources in some way. So we coded up low growth, and low growth, it just means low national growth, not state growth, national growth. And this is going to be a period where you have growth of 1% or less, right? So you can think of about this as sort of loosely being recessions. We can use other, cutoff points. It doesn't particularly matter. So what you see is that, first of all, it looks like we're just losing some power over here. So these are all 5-year intervals, and what happens as you translate from 36 to 99, where you have more data, is that you're getting sort of similar effects, but they're not statistically significant, in part because there's just, I think you're losing some power because the number of observations goes from 3,072 to 1,440. Okay, so oil looks fine in the sense that it's sort of roughly consistent across time, and it looks like you're getting slightly bigger effects when you have periods of low growth, right? So periods of low growth in some way magnify.
Wait, this is low growth with respect to the dependent variable or with respect to the employment?
No, this is low growth. National income growth has been less than 1%. Okay, so that's how we do it. If you have other ideas for the other specifications you'd like to see, that's fine too.
That's just you're getting off the dependent variable, right?
Yeah, although it's not the state one, but yeah, we can go with the official NBR recession, or we can. It's not going to matter too much how we exactly do it. Okay, so here we've got coal, and the thing that you'll see in the next slide, but you'll see it here too. So it looks like there's a differential effect of coal in this period, and not much in periods of low growth during the whole sample, but this big negative effect of low growth during the 70 to 99 period. So it does look like something interesting is going on here. And let's just go to, let me show you the other thing, and then we'll talk about what we think is going on. Okay, so again, when you go to coal income, so this previous one was employment, and this is income. So again, you go up with coal, you got these differential effects with declines, but the important thing is this, right, which we saw earlier, which looked kind of weird, basically goes away and suggests that what you were capturing here was in fact this effect that happens only during periods of low growth.
Is that what it is? I guess my thought is that's what you should see if low employment growth in, say, coal was associated with mechanization of coal, right?
Well, so I spent a little bit of time looking at this because I was worried about the correlation. So it turns out that actually these two things are not as correlated as you might expect, right? But I think that it's exactly this, that declines matter, but it's this mechanization. It's this basically if there's a decline and in periods of low growth you get mechanization. And so how do you want to interpret this? If you add up these coefficients, you're going to get a negative 0.1. And so what does that mean? It means that if you see an increase in income or an increase in employment, you're actually seeing a decrease in growth. But more naturally, if you flip it, right, you get a decrease in employment, you see an increase in growth, which is this benefit of diversifying away from the sector. And also, I think, and this is one of the things that we're sort of interested in looking at more carefully, this mechanization story.
Doesn't the dependent variable include change in oil income? The dependent variable is all income growth, right?
Yeah.
That's income growth in not oil plus income growth in oil.
Right.
So you're regressing change in oil income on change in oil income.
Yeah, this is partly why we do the employment thing too. It depends on how much of the oil income you think is exogenously determined by world markets. I mean, if you don't like it, we can certainly just focus on the employment stuff, right?
Yeah, the challenge with the employment stuff is it doesn't get productivity increases through mechanization, right?
Yeah,
So-
this is exactly why we like to compare the two, because unfortunately it's not quite as informative as we had hoped, and so we may end up kicking the sort of income stuff into the appendix because we're hoping that we're going to see bigger and clearer differences, which would help us better understand what was going on. The differences are they're different, but they're not different in a way that's necessarily quite as informative as we had hoped. Was that your question too, Anne?
No,
Anna?
I started thinking about the mechanization, and is there any way with your data to look at basically how much of the money is going owners of capital as opposed to labor?
Okay.
And I don't remember when you said your outcome data comes from.
Mm-hmm. So the BEA data might have, so you're thinking like wages?
Yeah.
Yes. I mean, so there are a couple things we could look at. We could look at employment per ton, which is going to get at this productivity issue. And I think for the later period, there's wage data. There's not going to be wage data going back to 35 that at least I believe is credible. But
I mean, I guess part of it, I'm just sort of wondering, you're looking at income per capita, but looking at the distribution of income would also be very interesting.
yeah. No, and that kind of goes back to your question as well. Okay. So there's coal income. So what do we want to take away from this? So far there's asymmetric effects of increases and decreases, which are at least loosely consistent with the boom-bust literature. It's not always significantly different, but certainly we're seeing that there's a positive effect and then a differentially larger positive effect with the bust. Also, that this idea that maybe it's the cleansing effect of recessions. That's what they talk about in some parts of the macro literature. But it seems to only be happening for coal. That may be because there just aren't that many productivity benefits in oil, right? Because if you think about how oil is produced, you drill, and then it comes out. And so the labor component is quite different. Whereas in 1935, when you're taking coal out of Appalachia, there's just a lot of human power happening there. And so that may be the reason why there are these differential effects. We're not entirely sure. Okay, so the other thing that we wanted to talk about, and again, in the spirit of these things that somehow end up being a little less informative than you had hoped, we look at the South to see if there are differential effects in the South, both for mining and for farming. And Yeah, I mean, I tend to think of these one-year things as not being very interesting. If you look at the 5 years, it looks like maybe the South is actually doing a little better in the sense that you sum these effects. So on the increase, it increases more. On the decrease, it would decrease more then. We tried, by the way, putting all of these three things together, the low growth, it just becomes kind of uninterpretable, and also you lose so much power that it's just really hard to know what's going on. Okay, so maybe this is happening. This was not necessarily our prior, because there's a lot of discussion in the literature about the South having sort of weak institutions and corruption and things like that, and so it wasn't totally obvious to us that this would be positive and not negative. What's sort of interesting here is the farm employment story, though, and this is where we're actually getting interesting. Somebody was asking, why are you looking at agriculture? And the answer is that it looks like these effects are sort of offsetting, or maybe not fully offsetting, but at least partially offsetting in the South. Which means that you see an increase in farm employment, you actually don't see much effect on income, whereas you do see a positive effect on income in the non-South. This may be because they have a lot of farm laborers that are kind of doing a lot of subsistence farming, and so it may be that seeing more farm employment is having a different effect than you would see elsewhere. So this may be a sort of shift out of agriculture, but yeah, we're not 100% sure. The other thing that you can see is that with income, here, the effects are a little bit negative, but again, not statistically significant, and most of the effects here seem to be because there was employment and somewhat related to income, but a little less related to income. So I think the main takeaway from the South is just that increases in farm employment and income are both good for the non-South, but are less good or potentially even bad for the South, and we're not finding many effects from minerals. I think we were a little surprised that the South didn't look more different. This may be partly because we've got a lot of controls in there already for being low, for these income year controls and these census division year controls, and it may be that that's picking up what's going on. Let me just spend 2 minutes talking about the replication results, because I think that these are sort of at least mildly interesting. First of all, there's cross-sectional growth regressions, which is what this literature was all about, and that basically, the time series component is what happens to your state over time as you see increases and decreases. The cross-sectional is quite different in terms of how we think about it. So this just says, look, we can, if you wanted to look at these relationships, you can see similar things to what other people have found, that indeed mining employment share in 1970, these states in cross-section grow more slowly, but it's not clear that that's very interesting. This is interesting because this is a paper by some economists who are finding something that's at least somewhat similar to what we're finding looking at this later period. They're finding positive effects. Some of the county level stuff finds positive effects as well. This is a paper by some political scientists, and with no disrespect, anybody here a political scientist? No disrespect to political scientists. These people put in a bunch of lagged variables, including lagged mineral shares and lagged per capita growth, and if you throw enough stuff in and your prior is that you're going to get a negative effect, you can get a negative effect. But you do want to be a little careful about that. Okay, so I'll just wrap up and then maybe there are a couple of questions. Oops. All right. Okay, so I think the main takeaway from this paper is that we need to take a much more nuanced approach, right? That is this whole idea that we would expect the coefficient to be, constant across all of these things, including constant across variation in the sector, variation in sort of the economic environment is a little bit crazy. And so, both of these literatures really need to take this heterogeneous effects much more seriously. The other thing I would put a plug in for is just doing some replication in order to maybe better understand why you get these different results. Once you did the replication exercises, you could clearly see it was just this choice of specification that was driving these differences, and that a different choice of specification could give you quite a different answer, a la, this. And so that these things are pretty important. Okay, so thank you.
So I was struck that the time series, they really didn't systematically differ, right? If you looked at the different chunks of time, I guess, you went out to look for it, but it seemed to me that many of that, if you just sort of looked at the whole paper and tried to reject that they were fundamentally different, I'm not sure you would do so.
You mean like?
1936 to 69.
Yeah, no.
Some are significant, some not, but they're just not very different, which I guess first is surprising because it's in many ways a different country. A great deal more communication, integration across space, highways, and all kinds of things. You would think that would affect the kind of relationship between resources and growth, the degree of integration, certainly.
Yeah.
And yet you don't see that. I don't know if you have any reaction to that, but it does seem like in this case you don't actually need a more nuanced perspective. There seems to be some rule, which seems crazy.
Yeah. Okay. So. Let's see. Let's go back a little bit. Here we're not actually. All right. Let me look for one where we're actually. Yeah. No. I was actually there are some differences.
Mostly within the standard errors. Right?
Yeah, no, and we can actually just estimate that directly. It's just not very convenient for presentation purposes. So, yeah, I actually was quite surprised that these results weren't more different. Although, they are somewhat different depending. Here's an example where the difference between, Matt, your question was sort of, well, why are we looking at income? Maybe we should only look at employment, and at least in some of these cases, it does look like there's some interesting differences, although here, it was really being driven by the fact that there are these differences in low growth. So your point would be abandon the different time period.
I just don't see a big difference between 36 and, between 36 to 69.
No, in some ways, part of it is we have a lot of heterogeneous effects right now, and we have to, I think, focus more on which of these are the most important. And so to the extent that we can throw some of these things into the appendix, I think it would help make the paper easier to sort of tell the story.
I would want to hear more of an explanation of why those periods. That is, in each of those periods you have a lot of ups and downs, right?
Yeah, and so
73 is sort of described as sort of a peak of the post-war boom, and then it's downhill from there. If you're talking about
yeah, so the main thing we did was we cut off the period that we knew people tended to analyze, and that just turned out to be kind of in the middle of the period, in part because we wanted to show that if you did this sub-period, here's what you would find. But I think, the point of, at least for some of the stuff, dropping, the intermediate period, the 36 to 69 period at least, so that we're not reporting so many results would be helpful.
Other comments or questions?
You said you needed to take a more nuanced approach. For me, it would be helpful to see more descriptive data of what this looks like at the level of sub-regions, in the South even,
Okay.
to see over time, is what happens to mining employment and what happens to
Sure.
agriculture employment and so on. And I guess I would say even, to lump the South all together is kind of like lumping these big periods that have ups and downs. That is, there's the more extractive South, there's a more agricultural South, there's even within Alabama, there's the Black Belt where they're using, they're doing lumbering, and we don't have lumbering here, that's another
Yeah.
kind of resource. But anyway, lumber and furniture, but another part of Alabama, they're doing, you know, lumber for pulp, which are two very different, anyway, so there's all this, you know, issues of sectors and the importance of how production is set up, whether it creates employment, whether it creates value added for the local economy, and stuff like that, so.
Yeah, and I mean, some of it is that we're looking at the state level and not the county level quite intentionally so we can exploit the earlier data. But no, I agree that even within, you know, Pennsylvania is a perfect example, right? There's a huge amount of heterogeneity in which counties have what and what the effects of those are. So it's
Right, I was using an extreme example, but let's say, just to say, in the South, if you could break it into, you know, 3 different groups of states, you know, ones that have petroleum extraction and others that don't.
Yeah, I mean, at some point you begin to have really small data issues, but yeah, I mean, certainly we could try and look at the South. I mean, the other thing is we're focusing here in the South is the Confederate South, but the sort of, that doesn't exactly map to the census region, so one thing would be maybe to look at the census region South, and then you would have slightly more states to subdivide.
Right. All right. Well, welcome you. Join me in thanking the speaker, and then we can go upstairs for the party.